So now we're going to look at how carbon dioxide and oxygen are being transported throughout our body, whether we look at the pulmonary circuit or the systemic circuit. This gas exchange is a very passive process, as we talked about before. So what does passive mean? It does not require energy, meaning it goes from a high concentration to a low concentration. So it goes with the actual gradient, right? So if we go review a little bit, we learned that the atmospheric pressure, ATM, is about 760 torrs, or millimeters of mercury, whichever would work. Both would work. And so based off of this information, right, so we've learned before in chemistry that 1 ATM or 1 atmosphere equals about 760 torrs or millimeters of mercury. So for the sake of this, we'll focus on millimeters of mercury, all right? And so this is talking about all the gases, first of all. So what kind of gases are there? We have nitrogen, we have oxygen, we have carbon dioxide, we have methane, right? So these are all the different gases that are present, okay? So the gas that are important that we're going to be focusing on today is oxygen, which is about 21% of this entire atmosphere. And then CO2, which is about 0.03%. All right, so very low level of oxygen, and the rest is compensated by nitrogen, right? And so if we put that in perspective, first of all, is what is the atmospheric pressure of oxygen in the atmosphere, right? So we're looking at the atmosphere, and so the partial pressure is about 160 millimeters of mercury, right? And then the partial pressure of CO2 is approximately 0.3 millimeters of mercury, right? So we're looking at the atmosphere outside. That's really important. And so during the breathing process, we have ventilation, right? And so ventilation is where you have the transfer of gases throughout your body, right? And when it comes to your alveoli here, so the first section, so this is where we have the final region of the respiratory system where all gas exchange takes place, right? So you have the alveoli coming in, and at the alveoli you have about a partial pressure of oxygen of about 100 millimeters per mercury, and for CO2 it's about 40 millimeters of mercury, right? And so this has to do with not only the atmosphere, right? But if you have to look at it, all the CO2 that is built up from the systemic circuit creates this 40 right here, right? And we said that this process is a passive process, high concentration to a low concentration, right? And so if we look at here, all of the blood that is being returned back into the heart from the venous circuit comes in, so the systemic circuit brings in all the blood. And before we get in there, this partial pressure in the venous circuit here is about, you have a partial pressure of oxygen of about 40 millimeters of mercury, and the partial pressure of CO2 is about 45, right? And so this blood at this concentration of oxygen and CO2 comes all the way into the systemic circuit where it comes in, and now we enter the pulmonary circuit. So here, this is the pulmonary circuit. This is where in the alveoli, and you have the capillary beds, the pulmonary capillaries, where you have the gas exchange taking place. So if this blood specifically here is coming in to this specific region, right, at this concentration, right, we want to see the transport of gas, right? So which way is gas going? So if the gas, this concentration, if I were to redraw it here, just for the sake of space, I won't, but imagine this number is here. What can you tell me about the direction of oxygen? So you can tell me, based off of this, that because there's a higher concentration of oxygen in alveoli and a lower concentration in the actual capillaries, the oxygen goes up or down. Oxygen goes into the capillaries. So it goes down. So it goes out of the alveoli and into the capillaries. Vice versa, if you look at the concentration of carbon dioxide here, concentration of carbon dioxide in the capillaries is much higher than the alveoli, right? So if this again is a passive process here, we can say that this carbon dioxide goes into the alveoli, right, in terms of direction, right? And so what would be your new concentration? So your new concentration now, this needs to equilibrize, right? So when this equilibrates, you have this new partial pressure now that leaves the pulmonary circuit and enters the systemic circuit, right? And so this new partial pressure is equivalent to about 100, but because some air gets lost, we say about 98 millimeters of mercury. All right, so 98 millimeters of mercury, and because the concentration of CO2 is already so small, we maintain our same concentration of 40, right? And so your new circuit that comes in here, comes into this area, right? Now you have about 98 millimeters of mercury that needs to re-enter this systemic circuit to help the tissues, right? So all this blood goes in, So before we actually see the actual gas exchange taking place, what do you think the partial pressure is here in the systemic circuit? So in the tissues, because when we look at cellular respiration, so what is cellular respiration? Cellular respiration is sugar, so C6H12O6 plus 6 oxygens gives you what? It gives you 6 waters, and it gives you 6 CO2, right? So this is the basic foundational formula for cellular respiration, right? And so based off of this, all of this metabolic byproduct, carbon dioxide, builds in to the systemic tissues, and all the oxygen gets used up. It gets used up and metabolized, right? And so the partial pressure here of O2 is about 40 millimeters of mercury. And the partial pressure of CO2 is about 45, because you have a buildup of this CO2 that's being created, right? And so again, here, as this concentration comes in to the systemic circuit, you have all of this gas that's dissolved into the interstitial space and needs to be transported into the vessels, right? So here, if I'm looking at it here, where does oxygen go and where does carbon dioxide go? So here, if the oxygen comes in here, we can see that the oxygen is at very high concentrations in the capillaries, so it goes towards the systemic tissues, right? And CO2 is much higher in the systemic, right, because it's buildup, so it returns back into the circuit. So what is our new concentration? So what would be our new concentration? When we look at the actual partial pressures of gases, so the new partial pressure of gases after it equilibrates from this concentration again, you're grabbing this here, this concentration, and putting it here so you can see it better. So transfer this here. And now after this equilibrates, you again have this same partial pressure. Now you have a partial pressure of 40, a partial pressure of oxygen of 40 millimeters per mercury, and then you have a partial pressure of 45 when we're looking at the partial pressure of carbon dioxide, 45 millimeters of mercury, right? And this constant process is a passive process. And from this, you can see that there is a gradient that is created for this for the oxygen and carbon dioxide that have been created.